Can you see the screen?
Yes, sir.
Okay, in our last class we are talking about the basics of pointers in C++, and the basic idea is both in C and C++ these basic things are same because C++ is C compatible. So we just try to recap all those concepts, and the new thing that will be in C++ is the operator through which we can allocate or deallocate memory, that is using new and delete. So that we'll be talking about in the next class. And also there is a new type of variable that is that is allowed to be declared in C++, that is reference variable. So those will be the new additions. So let us browse, go through the basic concepts. So what we mentioned was the address of an object or variable. This we cannot assign a particular, the programmer cannot fix a particular location for a particular variable. So it will rather ask the compiler, and the compiler will get it done via the operating system memory management module. But once it is done, then the programmer can know the address of a particular variable using address of operator. And storing the address, although addresses are nothing but unsigned integers, so these can be stored in unsigned integer variables, but they will not function properly when we perform different operations like addition or increment, decrement, like this. And also there are some type of operations like multiplication, division, which are also not so those are absurd in pointer variables because that does not make any sense. So that's why a new type of a special variable is required to store addresses and to deal with address operations. So that is what is called pointers or pointer variables. And because each variable type, they require different amount of space, 2 bytes or 4 bytes or 1 byte or even more. So to store the address of a particular type, we have to define that type of pointer variable. The problem is, although they are all storing the address which is irrespective of the type, that is always unsigned integer, but whenever you increment or decrement, then according to the number of bytes or the locations that that particular data type requires, the increment and decrement will be affected. So to get rid of the problem, a pointer variable, we have to specify what type of pointer variable it is. If it is integer pointer variable, it can only point to integers. If it is a floating point pointer variables, it can only point to floats, floating point variables, like this. And if we know the address, if we store the address of a variable in a pointer variable, we can use the indirection operator to know the content of it. And this is called indirection because if I know the address, I can point somebody to that particular location. So these are some of the examples that we tried. And another important point is, no matter what type of pointer variable it is, it will all require the same number of bytes. So a floating point pointer, integer pointer, a character pointer, they will all require same amount of space. Now it requires 2 bytes, but I mean the compiler that I have used to show the examples later on, you will find that the size of int is 4 instead of 2, and the size of float is also 4. Okay, so if the size of int is 2, then unsigned integer also will require 4 bytes. Sorry, size of int is 4, so the unsigned integer also will require 4 bytes. So therefore, in the examples that I'll show today, instead of it requires 2 bytes, it will be actually 4 bytes. So as I mentioned, it depends on the it varies from compiler to compiler, like that. Okay, but it will all be the same. So also we found that as the address of a integer can be stored in a pointer variable. So this is a it's a p1 is a integer, it's a pointer to an integer, this p2 can be spelled as pointer to an integer pointer, and this p3 can be spelled as pointer to an pointer to a integer pointer, or pointer to a pointer to integer, whatever way you can say. Pointer to an pointer to integer, like this or this. And if we have done that, so that is how we can schematically show how the pointers are actually pointing to the actual contents. So if they store the address, they are capable of pointing. And if this I is to be accessed through P1, I can use just one indirection. If it is to access to P2, it should be two indirection. Via P3, it should be three indirections, because P3 is 3 hop far from the actual contents of I, that is 15. Okay, but all the and the addresses of because these pointer variables also require some space, as it is found here, so we can display the address of the respective pointer variables. Okay, so the idea is P3, from P3 you go to P2, take the contents, you then go to that particular location, get the location address, and you go to that location, and then you do this. So that is how indirection means. Okay, and finally we are talking about the different legal and illegal operations on pointers. So one thing that we found is we can it is always recommended to initialize pointers, and if we don't know the address which need to be stored at that particular point of time, we can assign null value. And null, if you display the contents of null, can you say what value will be displayed after this assignment? If I store the contents of P, cout P, what do you expect? What value will be displayed?
It's a null only.
No, it will be, so it depends, again it depends on compiler, but the compiler that I have used will show you 0, right? So it is something some address which is not you can say a kind of valid address. Okay, so if you will show that if you assign null, and if you want to display the contents of that pointer variable, that is what that null value is storing, actually you will get 0, right? But again, that might vary from one compiler to other, so it is better to check it and infer. And otherwise you can always store specific addresses, I mean that is compatible and that is actually which is meaningful to this P. And because this you see this P and Q both are integer pointers, so the contents of one integer pointer variable can be stored in other integer pointer variable, so this also is possible. Okay, so you first store the address of I into P, and then contents of P is copied to Q. So now both P and Q are capable of pointing to the integer location I. But again, non-compatible assignments like a floating point addresses, floating point pointer variables value cannot be stored into an integer pointer because it is incompatible. And even if you try to do it forcefully by typecasting, we'll see that what happens. But if you try to do something like this 2005 to P, definitely it will not be allowed, because a simple integer cannot be assigned to a integer pointer variable. Okay, so now comes the decrement and increment operations. So if I have P assigned the address of I, say this is I, this is 5, then I write cout P plus plus. Okay, let us make it as plus P, right? To see the effect, pre-increment. Okay, let us make it pre-increment and pre-decrement. So can you tell me what the values will it display in the cout statement? Quickly, can you tell me? So P will be, so if I write cout P, what is P?
4.
5.
So P means it is storing here the address of I, that is say 4 initially. So this will be displaying 4. Now if I write plus plus P, that means 4 will be incremented by how much?
So 1, 5.
No, not by 1, because it is pointing to integer values, and each integer takes how much?
2.
Yeah, but yeah, that's what I told. But the compiler that I'm using, it is using 4 bytes for integer, right? So now from now on, it is better to, you know, the one that we'll be using will be talking in that terms. So how much it will be incremented? What value? Plus plus P?
8.
8, right? So it will be because size of integer in our case, size of int, it's basically 4. Size of float also is 4, not 2. So then plus plus P, then what value it will be getting next?
12.
12, then
12.
it is becomes 16,
16.
then it becomes again
12.
again it is 12, like this. So what about this one? Cout this one. Again I make it pre-increment instead of post increment. So what values will be there?
20. Then 20.
So this R will be, you see, it is getting the address of F. So F's, what is the address of F? What is the address of F? This is F.
9.
What is the address of F?
9.
It's 9. Will be storing here, R will be storing the value of 9 in binary, right? Now if I write plus plus R, what value do you expect?
13.
30.
So 30, because float also requires 4 bytes in this compiler. So it will be incrementing 4 bytes each, right? So plus plus R, it will be
17.
17.
this will be 21
21.
and this will be again
17.
17, right? So this is fine. So add and subtract a constant value. So in this case, if I ignore these previous increments, right? If I ignore this, so if I again store the value of address of I to P, that is 4, and if I execute this statement, what will be displayed here? Somebody has switched on the audio, so please switch it off, microphone, some of you. Okay, so what will be the value of P here? What is the value of P before it got added to that 3?
16.
It was 4. It will be 3. 3 means each time it is by 4, right?
16.
Yes.
16.
So 12. So it's basically 3 into 4, 12 plus the original value of 4. It will be 16. What about this value of R?
1.
R was originally storing the address of F, that is 9.
1.
So it will be
1.
yes. So it will be 9. 9 minus, it will be 2 into 4, right? 9 minus 8. So 9 minus 8, just a minute. So 9 minus 8, it will be 1. Okay. So we find that initialization is possible, increment and decrement of the assignment variables, the contents of the assigned variables it is possible, but we will follow strictly pointer arithmetic. That is the point. So it follows pointer arithmetic, and a constant value also can be added or decremented, or added or subtracted. That is also possible. But what is not possible is this addition, subtraction. Multiplication and division. So this is forbidden. So you are not allowed to do this. So then what about this one, subtracting one pointer from the other? Now if P1 is this 2005 and P2 is 2008, so let us check the other one. So P2 minus, because P2 has got a higher address value, P2 minus P1. So what value will be displayed? What do you expect? P2 minus P1.
7.
What value will be displayed?
7.
7. 7 means why 7?
So 13 minus 5, sir. So this is 12 minus 5, sir. 12 minus 5, sir.
So
Sir,
this
12
is
minus
5
5.
and this is 12. So will it be 12? So what is the interpretation of this? What do you try to interpret out of it? What do you expect? What is the physical interpretation of P2 minus P1? P2 minus P1?
So the locations of P2 minus the location of P1.
So if I say that your room number is you are staying in room number 3, just try to understand. Your room number is room number 2, and each one of your friends, including you, are occupying 2 rooms in a row, right? I mean 2 consecutive rooms. So your previous friend has occupied room number say 1, sorry 1 and 2, and you are occupying 3 and 4, then 5 and 6, like that. So
28, sir.
you
So it'll be 28, sir. 7 into 4.
No, I mean just let me come to the point. So the point is, so room number 1 and 2 occupied by say roll number 1, then 3 and 4 is roll number 2,
So I
and
think
then
it's
4 and
4.
5 say 5 and 6 is roll number 3, and 7 and 8 is roll number 4. Now I say, what is the address of room number roll number 2? It is 3. What is the address of roll number 4? It is 7. So if I say address of roll number 4 minus the address of roll number 2, what do you expect? I am asking that how many rooms far is roll number 4 from room number 2? Are you getting my question? So
Sir,
I am
it's
not
4.
asking I am not asking for the number of physical rooms it is far apart. I am asking for how many rooms means how many these units it is far from.
1.
So what will be the value here?
1.
Yes, so it will be 7 minus 4. It is basically the arithmetic will be 7 minus 4 divided by the size of each allotment. The size of allotment. So what will be the value here? I'm not sure about whether it is
3, sir.
it will be having
3, I guess.
yes. So this may not be properly aligned because but it will be actually this one, right? So it will be the difference of the address divided by the size of the data type, whatever it is, in this case size of int. What the point? So it's basically asking how many it is not how many locations exactly, rather how many say in terms of integer blocks it is far from. Have you got the point? So it is not the actual number of locations it is far from, it's the difference. Is that fine?
Yes, sir. Yes, sir.
So next comes a comparison of 2 pointer variables. So if we compare, so keeping in mind the same, so this type of allocation, okay, so 20520. So what will be the, so comparison means 2 pointer variables can be compared, the address of P1, address of P2. So what do you expect here, here and here? So it asks that if is P1 is same as P2, both are pointing, so this means are both pointing to the same location. What will be the output?
False, sir.
0.
It will be 0, right? 0 or 1, there is no false displayed. So what about this one? P1 is less than equal to P2? Yes, it is. Then P2 is not equal to P1, it will be
1. 1.
it will be true, right? So that way it works. So the legal operations are initializing null and or any compatible value, these are legal. Increment, decrement according to pointer arithmetic is legal. It will perform pointer arithmetic. Addition, subtraction of constant value, this is possible. Subtract from one another, again following pointer arithmetic, right? And then comparison, this is also allowed. Illegal operations, initializing direct values, this is not possible, or incompatible types, this is also not recommended. Even if you forcefully type cast, it is not recommended, and multiplication division will simply not work. Okay, so that's a summary of the legal and illegal operations on pointers. Is that fine?
Yes, sir.
Yes, sir.
Let's come to this illustration where I have just, I'll share you the code. So I have just copied this part. So as you can see here, can you see? Can you? Is it visible completely?
Yes, sir.
Yes, sir.
Yes. So You see here I am displaying, I'm talking about the integer pointers. Now I have initialized p3 to null, right? So p3 is assigned null, and then p4 is assigned some value 2004, which will be strictly prohibited. So if I have typecasted it to integer pointer, probably it will work. I mean, it will allow this to happen. But then if I would like to write, p3, so what is the value of p3? I would be expecting the value of the null, right? So what it displays here, p3, the value of p3 is null, I mean 0. So corresponding to null, it displays 0, at least in this compiler. Is that okay?
Yes, sir.
So now let me come to this part. So you see here, I think still it is visible. So what I have done, so this part is fine. So now what I have done, p4. So do you think that this will be allowed? I am forcefully trying to assign the value 2004 into p4, which is an integer pointer, and because it probably will not allow, I have forcefully typecasted it, that treat this 2004 as an integer address. Do you think that it will be allowed and it will be compiled? What do you think? Tell me fast, because don't take so much of time. These are all things that has been taught in your first year. Will it
No,
work?
sir.
Will it be compiled? Yes or no?
No, sir.
Okay, let's see. It compiled nicely, right? So that you were expecting that it will not work, it has worked. But the thing is, you see, once it has worked, if I give the output, you see it works perfectly okay, and the null pointer assignment, the value is 0. Can you see that
Yes,
here?
sir.
So now the
Yes, sir.
null value is 0. Now let me uncomment it, right? So now it has somehow allowed me to assign such value, typecasting the value. Now if I try to access that address, so I don't know who is having the contents in that address. It may not be it may not be permitted, maybe within the, I am as a user, it may not be within my user space, right? So all those details we'll know, but let us see what happens if I try to, I have not saved it probably. So if I save it, let me try it. What happens now? What happens now?
So
Segmentation fault.
segmentation fault has
ক্লাস
occurred.
নিচ্ছি না, এমনি করে কথা কিন্তু বলো না unnecessarily. হ্যাঁ, so what happens now? There is, can you see this?
Segmentation fault.
Yes,
Segmentation
sir.
fault.
Segmentation
Why
fault.
segmentation fault? Now the thing is, if you don't do this, if you don't typecast it like this, okay, if you don't typecast it, then you try to compile, you see what happens. It will not allow you to assign also, right? Because it's just an integer, it is not an address that you are trying to assign. It will stop you. But if you somehow get rid of it by writing that, okay, if you are not happy, treat it as integer address, right? And then if you try, then you say that I warned you, and you force me to accept it. And if you are trying to access the address location, I cannot allow you because you are doing something illegal. So this segmentation fault appears. And how the memory management module handles it, that you can see in your operating system class in details. But this is what happens, right? So you are not allowed to do that. This is not possible, right? So here, if you get back to the presentation, so now let's see. So this is I and j, two integers, and both the addresses of I and j are assigned into p1 and p2, both are integer pointers. Now if I see difference of two pointer variables, that's what we are arguing for some time. So what value you expect? So you see the p1, now first of all the addresses will be shown in hexadecimal, right? 0x means hexadecimal format. So it will be probably not very readable for you, but again we are happy with this because these days RAM, the size of the RAM is in the order of gigabits, right? So you cannot expect small addresses. They are typically large, and even if it is converted in hexadecimal, they will be containing several hexadecimal digits, right? So it will be not 10, 12 like that. So first of all, so this is P1 and this is P2. So if I write P2 minus P1, so what do we expect here? So if you perform the arithmetic, so this is 0. So this is A and this F. So if you subtract, it will be probably 1. So this actual subtraction divided by the size of int, that is 4. So if you carry on that, you will see that it is actually 1. As you can see, this is not, if it is location wise difference, it will be not be 1, right? Hello?
Yes, sir. Yes, sir.
So got it? So that come to the next point. Say this part we already found it, that if you compare and equality, so this will be 0, 1 like that. This is fine. Size of int, in this case it is 4. Can you see here? So this is 4, and then this is, if I increment that, you see, so size of int is 4, and if I increment P1 earlier was 699 FC. So if I add 4 to C, how much will be the value? C means what? C means actually 12, right? In hexadecimal, C means, in decimal it is 12. So 12 plus 4, it will be 16. So 16 will be again starting from 0. So that's why it is 0 at the end. You just focus on the last digit. You don't have to add also, right? So it is actually performing pointer arithmetic. Hello?
Yes, sir.
And if you decrement it, P2, so P2 was 0, 0. If you decrement it, it will be getting some 12 value. So that's why it is C. And P1 plus equal to 2. So it will be, so P1, what was the value here? P1 is 0. So plus equal to 2. So that means how much will be added? 8 will be added, 4 plus 4. And it becomes 8 here, you see. So I think you are convinced that it is pointer arithmetic. Then floating point pointers. Then again, we have two floating point values. We have assigned the addresses to PF1 and PF2, and then size of float, it will be 4, right? And PF1, PF2. So the floating point addresses, those variables addresses are displayed here. If you add it, so from 4, because float points, float variables also occupy 4 bytes, it will be from 4, it will be incremented by 4, it will be 8, right? And these, the rest of the things are easy to follow. So then comes this part.
Sir,
So
sir, sir, PF2 plus equal to 2 increments only by 2, sir.
which one?
Sir, in that line which you were explaining, the last output. Sir, PF2, the value of PF2 is incremented by only 2 if we add 2 to it.
Are the all the rest of it is same?
Yes, sir.
Okay, let me check it here. Okay, I'll check it there itself in the while I run the code. I'll check it there. Okay, so let us focus on this first, and I'll come to it later. So incompatible. So here what I am trying to do, P1, which is an integer pointer, I am trying to assign it to a float pointer. Will it be allowed normally? If I simply write P1 assigned to PF1, will it be allowed?
No, sir.
No. But if I forcefully typecast it as float pointer, it will be allowed. But it is up to you to accept, knowing that it is it might create problems. Because if you
Hello,
increment
sir.
now, it will be yes.
Sir, you have mistakenly written PF1 for
One
that output.
plus two in the code. Yes, sir. Sir,
Yes,
here,
sir,
here.
that,
Yeah,
Down,
sir,
down.
not there.
That
Yes,
is
sir.
got the
float,
point.
float, float, float,
In float.
float.
I got the point here. No?
Yeah,
Here
yes, sir.
I've copied actually and copy paste, and that is a problem.
Yes, sir,
Anyway,
that will be.
yeah. Thank you. So that's fine. So the otherwise there will be no mistake because I'm running the code and giving the outputs. Anyway, I'll modify it before sending it to you, right? Okay, thank you. So here P1, if I forcefully typecast, it will be allowed. There will be no compilation error, but it is up to you that you are accepting your fate, right? You might end into some garbages and all this later on. So size of various pointer variable types. Now, if I size of int asterisk, size of float asterisk, size of character asterisk, you see all are how much? So any pointer variable in my machine, how much it will consume? Same as that of integer, right? Or how much? Hello? How much it has consumed here?
Same,
Eight.
same.
Sir, 8.
8.
It has
Double.
it has consumed eight bytes because of the large RAM size. That is how the architecture is. So instead of 4, it has consumed 8 bytes. Okay, so it is probably treated it as a long int kind of. Okay, so that's why 8 byte, 8 byte, 8 byte. So as I mentioned, so it is better to check in your machine what kind of values are, but irrespective of the type, they are all the same. That is a point to be noted, right? So now come to this part where it is multiple indirection. Okay, so in the multiple indirection, you see this is x, then address of x is in asterisk px1 pointer to integer. Address of px1 is stored in a pointer to integer. Address of px2 is stored in pointer to integer, pointer integer, right? Okay, 3 indirections. So if I display the value of x, asterisk px1, double asterisk px1, triple asterisk px1, they will all display the same thing because it depends how far you are, and the number of indirection operators that you need to use is depending on how far you are from the original integer variable, right? So it takes you to that location, and if you consider that the value contained in x is packed in a box, so using the indirection operator, you can unpack that box and see what is there inside, right? Is that fine?
Yes,
Yes,
sir.
sir.
Okay, so I'm not switching to that code part. It is all the same. I'll pass it on, send it to through the email. So now let's focus on the constants in C++. So in constants in C++, the point is in C, you have probably many of you have used hash define to define constants. Like pi, sometimes you have written hash define pi space 3.14, right? Because it's a constant value. So many other cases you have used that. But in C++ or even in C later on, the const keyword has been provided. And using the const keyword, you can declare a constant. It is not, so hash define means it is basically a macro, and that symbol gets replaced with the value. That was not, so even before the compiler starts compilation, all the symbols gets replaced by those values. That is pre-processing part. But when you use a const keyword, so it will be a request to the compiler to treat, so in this case const int I, so it will be request to the compiler that this integer constant I should be treated as constant. So if you write I and if you write I plus plus, what will be the case? I mean, what will be the value displayed here? I will be 5, but I plus plus will be,
Just
what
to
will
remain I5 only, sir. 5.
no, it will not be remaining. It will be simply not allowed, right?
Okay.
It will not be allowed at all. So it is not that you are allowed. So you are trying to do something that is illegal, trying to increment a constant value. Because you are, so this is a directive to the compiler, so the compiler will not treat this. So it will say that just now you told me that I is a constant integer, now you are trying to increment it, so what is happening like that? Okay, so it will not be compiled. So the thing is int, but in C++ this nice thing happens, right? If you have declared a constant integer, integer constant, we know that when you declare static arrays, so you have to specify the size, right? Static arrays means you have to specify the size here. So this size can be a constant integer that you have declared earlier. Generally, we used to write here 5, 10 literals, we used to write values, we used to write, but you can replace it, or you can write here instead a constant integer name. Is that okay? Now, can you see what is happening here? Character C, C in C, C, you are taking input of the character C. Now this constant character X, so this X is a character constant, right? Now you are trying to initialize. So the first thing that need to be known is any constants need to be initialized, must be initialized. So here we have initialized I. Now here we are trying to initialize X. Now what is the nice thing here is whatever, so what is this? While you are initializing, you are using a variable, whatever you have read the contents of the variable plus a, you can initialize. So while you are initializing, you may not have a constant value always. While you are initializing a constant, you may not have a constant value like a or b or c. or 12, 15 like that. You can also have some variable and the contents of the variable will be considered for initialization. And here in this case, you can see that while you are, so in the runtime, it is getting the value, because you cannot get the value until unless you run the code, and you at that point when you run the code, you get the value and you initialize it there. And once it is done, you cannot change it any further. So that's the point. So a constants in C++ does not mean that you have to always pass on fixed values. You can, in runtime also you can initialize. So the thing is, we can say that runtime initialization is allowed in C++. Is that fine? Is that okay?
Yes, sir.
Any question? So now comes another point, that constant C++ constant entities are allocated space. Now you say that so the question might be like, variables require space because you keep changing the values with time during the execution, but constants, they retain the same value, they don't need to change it. So the thing is, now there's a point, or there's a debate whether if you are not requiring to change the contents of a particular location, whether you actually allocate or reserve some space for that, right? So the thing is, in C++, it is handled in both ways. So this allocation of space is always not compulsory. It is done only if there is a runtime initialization, we are evaluating the address of the constant, or there is an aggregate constant that is defined. Aggregate constant means this is a constant int, so it's an integer array which is treated as constant. So none of the elements of the array you cannot you can change, right? So if any of these three happens, you basically are forced, or the compiler is forced to allocate some space for that particular constant. In other cases, like in the previous case, like here, you have basically use a value of I. So simply constant I, int I equals to 5, and not asking for the address or anything like that. The compiler may keep allocating physical space for that constant. Is that fine?
Yes, sir.
So in this case, if I write here cout A0 plus plus, or A0 maybe 0 or 1, whatever, will it be allowed? It will not be allowed, because this is a constant array. That means none of the elements of the array can be incremented or decremented. So all are fixed, but it will be allocated some space, because in all these three cases the space allocation takes place. Now consider the 4 cases, right? So now we see the relation between constants and pointers, because we are basically talking about pointers, and there is some way of these two are related, right? They have some kind of relation. So in the case 1, you see, can you read this? What it says? Integer I equals to 5. So integer variable I is assigned the value 5. It's like this. Then this is integer pointer variable, right? P is a pointer to integer variables. It's a pointer variable which is assigned the address of I, right? So now that means this 2005 is copied here and it is capable of pointing. So what will be the output of this? This is simple. So this P is a, just tell me the, do it fast. So tell me the answer. There is no trick here. So P is a pointer variable pointing to a integer variable. Okay, is that fine? So P is a pointer variable and pointing to an integer variable, although it seems to be very trivial, but we'll see that things are not trivial. I mean, we have to specify that this is a variable. So P is a variable and whatever it is pointing to is a variable. So what will be the value of I? P, what is I? 5.
5.
What is the value of P?
2005.
2005.
Whatever, what about, sorry, it is I plus plus, let it be pre-increment.
6.
So it will be 6. What about this one?
7. 7.
It will be 7 because just now it was 6 modified to 6 and then it will be modified to 7 like this. What about this plus plus p?
2009.
2009.
009 because 4 bytes. What about this one? Now first of all you see this is the same, but this is what I have tagged the const keyword here. So how you read this declaration? The declaration of p, how you are going to read this? So p is what? P is a
Constant integer pointer. Constant
just tell me, is p still a pointer variable or a pointer constant? Please switch on the switch off the microphone. I mean, somebody has switched on the microphone. It's the lot of noise coming on. Can you please switch it off? Yes. So tell me fast because I have got few more stuff to show. So p is a, what is p? So p means this. So what I mean to say is, in the previous case, this box, the contents of this box and the contents of this box both can be changed, right? As you can see here, I plus plus and this, so both can be changed. But here, what is p? So is p still a variable or a constant? P is a pointer.
So P is still is a constant now, sir.
P itself became a constant? No.
Oh, sir, no, so the pointer.
P is a pointer variable pointing to
A constant.
pointing to a integer constant, right?
Yes, sir.
Pointing to a, earlier it was integer variable, now it is integer constant. See the change here. So now the point is, now whoever it is pointing to I was originally a variable, right? But you say that now I assign the address of I to P, and I expect that P should treat the entity that it points as constant. That is all what it means. Is that fine?
Okay, sir.
So this means that P, so this originally is not a constant. I is a variable, but via P, if you want to access it, now it should be treating as constant. So like you yourself can modify your contents of your room, your hostel room. You can do anything. You can throw out things. You can put in things, whatever you want. I know your room address. Okay, you have given me the room address, maybe the lock key also. So I am not supposed to, I can open the room, I can see what is there, but I cannot modify the contents. Are you getting the point?
Yes, sir.
So me be a pointer to your room, I cannot content. So via me, no change can take place. So now tell me which one will be allowed and what values will be there. I will be 5. P will be 2005. Plus plus I will be
6.
yes. So because you are changing your content, so you are variable. But this asterisk P plus plus means what?
Not allowed.
So this is not allowed. So you cannot simply compile this like this, because you say that you just now told me that P should treat whatever it points to as constant. So how this is possible? This is not allowed. But P plus plus
2009.
2009. Now, so the thing is P is still a variable. So that it proves that P is still a variable. So it can point to sometimes at P 2005, sometimes it can point to 2009, sometimes at 2013, whatever it wants. So I can point to roll number 1's room, roll number 2's room, roll number 3's room. I am a variable, pointer variable, but once I get into that room, I cannot modify the contents. I should treat the location pointed by me as constant. Is that difference clear? Hello?
Yes, sir.
Yes, sir.
Now tell me that if I just place the const keyword here, if I just write int const asterisk p, sorry. So if I just place it like this, what will be the interpretation?
Pointer constant.
No, it is still the same. So placing the const keyword here or here, the meaning does not change. Okay. So if I want to make p as constant, where should I place it? What is the only option left? I want to treat p to be constant. So I can only point to CR's room and nobody else's room as a faculty. So how should I ensure the constantness of p? So this is the first time we are trying to talk about a pointer constant. Till now we are talking about pointer variable like this, even up to these two cases. Now I am going to declare a pointer constant. Where should I put the const keyword? Tell me quickly. So there are only one option left.
After pointer. Between star and P.
Right?
HT can P.
Got it? So how do I read it? P is a pointer pointing to integer dash. So what is this? P is a pointer.
Constant.
Constant.
Now P is a constant, but pointing to an integer
Variable.
variable. So now P's contents cannot be, once it is initialized, you cannot change it. So now which one will be allowed? Which one will not be allowed?
Last one. The last one.
Last one will not be allowed, but all others will be allowed, right? And we can figure out the values. And what about this one?
Last two will be not allowed.
So P is a pointer constant pointing to a integer
Constant.
constant. So now you see both are constant. So although the original element was not constant, but once you assign the address to P, which is the way it has been declared, it says that I'll not point to anybody else once I'm initialized, and through me there will be no change that will take place in the contents of that entity, right? So which two will be not allowed? This also. Is that okay?
Yes, sir.
But
what about I plus?
Which one?
I plus plus
is always, it will always work, because I plus plus will always work, because I is not a constant. So that is what I mean. I means the original person. So you can modify your room's contents, but via me I cannot. Via me there will be no change. Are you getting the point?
Yes, sir.
That is what it means. So the way via P, so the original entity is a variable, but when you are trying to access the contents of the entity via some constant pointer, via some pointer pointing to a integer constant, the pointer will treat that entity as constant, and you cannot make any changes.
Hello, sir.
Yes.
Sir, can you please repeat why you write const before int?
Before int.
Yeah.
Here.
Yeah, in case 4.
Yes. So the thing is, this means what? The pointer variable itself is a constant, right? So once it is assigned the value, you cannot change it. You cannot modify or change it. P plus plus, P minus minus will not work. And this const means, you get back to the previous one. What it means? Whatever P points to should be treated as constant, right?
Then what is difference between const before int and before p?
That is what I am telling. So the thing is, if I put const in both the cases, that means neither P plus plus P is allowed, because you have done this one. Okay, because of this is not allowed.
Okay,
And because
okay.
of this is not allowed. Is that okay?
Yeah, thank you, sir.
Because of this is not allowed, and because of this is not allowed. So you are trying to, nothing can be changed by this. It's a perfect. So and there are many applications of this. It's not just for theoretical, just knowing the tricks and playing all the possibilities. That's not the case. Sometimes sometimes we need to pass some arguments into some functions when you are calling the function, right? So say in the main function I'm calling f1, and I'm trying to pass some local variables or some global variables value, say x. Now what I say is I pass the value of x, but you make sure that you don't change the contents there. You can only access it. So can you name what type of functions can be there where the local arguments of that function can get the value, but maybe through a pointer. If you pass it through a pointer, So the pointer gets address, but within the function they cannot change the contents. What may the example of the function where we really don't want to have it? There are reasons not to allow this. If it is a display function, right? In a display function, you are just trying to access the contents and you are trying to display it, right? You are not going to change the contents of any of the locations or any of the structures or whatever. So then, but you need to pass the address of the structure. So there inside you cannot make any changes. So in a display function, it should be probably treated as a pointer's variable pointing to a constant entity. So that inside no changes are allowed. Are you getting my point?
Yes, sir.
So even by mistake also, if you try to do that, it will be strictly, I mean, the compiler will give you error message. Okay, you cannot do this. So it is for safety, you can do that, and that will ensure the compiler itself will ensure that by mistake also you are not going to change anything within a display function. Is that fine? Okay.
Yes, sir.
So this is a summary. So this is pointer to constant integer. The const can be placed here or here. This is a constant pointer pointing to the integer variable, and this is a constant pointer pointing to a constant entity, right? So this is what it means. And okay, I think I have the, it's already there. Oh, okay, the example is there. Do not switch to the. So can you see this code? So what I did is all these 4 cases, and I think now it is no need to explain it once again. These are all clear. So in the last case where I have considered both as constant, okay, PC4, this value of y and y plus plus, this is allowed. Okay, so y plus plus is allowed here, but plus plus PC and both of these two are not allowed. So you can just go through the code, then this is pretty simple. I have just shown that this is not allowed here, and you will say that then what kind of errors it will occur. So it will not allow you to compile. So if you try to uncomment it in this first case, which is the entity, if you want to update the entity via the pointer variable, there will be a compilation error. It will not be allowed. So the compiler itself helps you to know that constants should not be modified. Is that okay? Okay, let's come to this part. I'll take another maybe 10 minutes of time. Will that be okay? So I would like to correlate the arrays and pointers. Another 10 minutes. Hello?
Okay, sir.
Okay, sir.
Yeah, because you just had one class, so you need to get these things because these are very important. Otherwise, the rest of the lectures you will not be able to follow. It will be completely, it will be of no use. So that's why and although these are all repetitions, I believe that these things are taught in your first year courses also. Now, whether you can recall it or not, that's a different thing. Okay, so what is the first line? Int A4 2468. So it's a, what is this? What is A? What is A? A is a,
Array.
Sir, is a pointer.
Is a pointer pointing to this.
no, A is, what is A? Okay, don't think too
Sorry, it's an
very
array, sir.
complicated way. It's a one-dimensional. It's a one-dimensional integer array. Okay, I understand. So once you know the things, you will start answering in a maybe in a different way. But right now, it is just a one-dimensional integer array of size 4, static allocation, and that too static because now till now we have not talked about anything dynamic. So once that comes now, why we say it's a static, that makes sense, right? So it is a one-dimensional static integer array of size 4, and what it means, so it declares the compiler that let me have a contiguous allocation of 4 integer elements. Contiguous means one after the other, just one after the other. It requests the compiler to allocate contiguously the space for 4 integer elements. Okay, and that's what it has been done, right? So this may be a sample allocation for this array that we have declared. So it is for 2, the first 2 locations storing again I have not shown it 4 bytes each, okay, but that does not really matter. The overall interpretation will be the same. So let us assume that it requires 2 bytes only. So 2, then 4, then 6, then 8, and in binary they are storing things. And 2008, 9, 10, 11, 12, and so up to this. So these first 2 bytes, it is A0, this is A1, this is A2, this is A4. So can you tell me what will be the output of this cout? So what values you will get here? Tell me quickly. Don't take so much of time.
So 2008.
2008.
So when I say what is meant by this address of A means, it is basically so A requires how many locations? A requires how many locations? 8 locations, right? So it will be the base address of the entire block of locations, right? So it will be 2008. So that is fine. What about this one? If I just write A, will it give an error message or it will display something?
Sir, 2.
Huh?
2.
Sir,
2008.
2008.
2008.
sir.
It will be this, right? So then what it means? Now can you tell me what A is? So
Base
A
address.
is, so A is basically some pointer, right? So A is storing address, but A is basically a pointer. Now you have discussed about pointer variable, pointer constant. So can you say what A is? So right now at this moment, if those who are not convinced, I can show you. So if it displays 2008, you can at least what you can say about A. What is A? A is a pointer, right? Is that okay?
Yes, sir.
Now if I write A plus plus, then what will happen? What will be displayed? What will be A plus plus?
2010.
Sir, 2010.
Sir, error will be there. Sir.
Yes. So now can you tell me what is A? We have some more clues. So A is a pointer. What is A? A is a pointer.
Constant pointer.
Constant. Pointer constant.
It's a pointer constant, you can see. It's a pointer constant because A plus plus actually means A equals to A plus 1. So you are not allowing me to. So A is a pointer because it is displaying some address, but you are not allowing me to increment or decrement. So that means it is treated as a pointer constant, right? Up to this much it is fine. Now if I write A plus 1, will it display anything? Tell me quickly. A plus 1. Will it be error?
Yes, sir.
It should display
So
2010, sir.
Sir, 2010, sir.
It will
Sir,
be
2010.
Okay, somebody says it will be 2010. Then any other answer?
So it will be an error only, sir.
It will be error. Are you the same who spelled error in the previous case?
No, sir, no, sir.
So who told me error? What will be the answer? Here somebody told error. What will be the answer here?
2010.
2010. So both are correct. Now you see. So now what A is a pointer to, you see A is a pointer constant, and it is basically pointing to this entire box, right? So it's a kind of integer pointer. It's a pointer constant pointing to integers, right? That much we can say, because you see whenever you increment 2008, it's not increment, you add 1 to it, it will be pointing to, or it will be doing plus 2, 2010. Again, if you write A plus 2, what value it will get? It's a constant, but if you add 2, it will add up to this value, right? So it is plus 1, this is plus 2, and if you say plus 3, it will be getting this, and here, right?
Sir,
Plus.
what is the difference between A plus plus and A plus 1?
A plus plus means you are trying to increment A and update the value of A. And A plus plus means you are just trying to add the value and display it. No storing. So the contents of A is not modified. Are you getting the point?
Oh.
This is fine. You can add anything. It's a simple arithmetic. But the contents, if you want to modify the contents of A, then you are not allowed to do that because it's a constant. Got the difference?
Yes, sir. Thank you.
So now, so the thing is now what we can infer out of it. What is A? A is a, what is the nature of A? Can you say what is the nature of A? So the nature of A is something like this, right? Int asterisk const A. So it's not a declaration, but it behaves like this, right? Do you agree?
Yes, sir.
Yes.
Hello,
Behaves like this?
hello, sir.
Yes.
Sir, what will be the name of error when we are trying to increment the value of A?
What will be the name of?
When we try to increase
No, we are
the
not
value.
incrementing A. You are not getting things probably. So we are not incrementing means this one. Here we are trying to do. We are just adding some value to A. Incrementing means you are adding and you are updating the value. Incrementation is not allowed at all. Here what it means, you are just adding a value and you are displaying the value. There is no storage.
Yes, sir. Not here, sir.
Okay, then
A plus plus, sir. In A plus plus, it is not allowed. Then what will the compiler generate?
now there will be a compilation error. You will not be allowed to do this. There will be a compilation error, and this particular statement you cannot write.
Okay.
So wherever I am putting a cross means you cannot compile the code with having that intact. You have to comment it. You have to remove it. Got it?
Sir, here is saying L value required, sir. My compiler. Sir.
Yes, that is the point. So what is the L value? What is the L value here? You see,
Sir,
L
left
value,
value.
L value is here. This one A. A is a constant. If a constant is in the L value, you cannot do that. A constant can be initialized once and it cannot be modified later on. L value required means here it
Yes,
expects
sir.
a variable L value. That is what it means.
Oh,
Got it?
yes, I got it. Okay, sir.
Okay. Now can you tell me the answers for this one? If I write C out A plus 0 and if I write C out A plus 0 asterisk. Now quickly tell me the answers because
So 2008, then 2, then
2001.
201.
see, A was 2008 and if I add 0 to it, does it make any change?
No, sir.
No. But if I put the asterisk, what it means? Yes. So now, so you can interpret. So here it will be value 2 here. So what you can interpret here. So if you are is A plus 0 means you are outside the box. If you have A plus 0 asterisk, so this asterisk allows you to break open the box and you are here inside, right? So asterisk means you have jumped inside. You have broken the seal of the box and you are inside like this. So that way you can interpret. So there is no such boxes. There is logically we can intuitively we can see the whole thing like that. Now if I write A plus 1, so A was this. A was holding the value 2008. A plus 1 means what? A plus 1 means 2010. And if I give a asterisk means you can break open the
4.
box and you are here. What you
4.
can see here?
4.
So here this asterisk is basically you are breaking open the box, and this A plus I, this is fine, and this A plus plus will not be allowed. And what about this one?
Allowed, sir.
So what value will be here? Okay, let it be like
3.
this. And
3.
again the same thing like this. What will be here?
3.
A plus 0 asterisk. A plus 0 asterisk is 2. 2 is incremented, so it will be displaying 3, right? So now what can I say? So A plus I is equivalent to what? So this is the pointer notation, right? In the index notation, A plus I means you are trying to get what? The address of the ith location, right? So this is the address of the 0th element. This is the address of the first element. This is the address of A plus I should be the address of
ith element.
ith element, right? So in the array notation, what do I write?
A square bracket I.
Then address of the ith location.
Yes, sir.
No, the address of ith location. What it means? AI means the contents of the ith location. I am talking about the address of the ith location. You see, what is the equivalent of A plus I?
Address of operator in Front.
Yes. So they two are same, right? They are analogous, right?
Yes, sir.
Now if I write a plus I asterisk, what it is equivalent to?
A of I. A of
A
I.
of I. Now both are same. I mean both are exactly analogous. The ith location, the ith element, and is the ith element. So now even if you have used a static array, you see there is a static array. There is no question of pointers. Have you ever mentioned pointers here?
No.
Have you ever mentioned any pointer name here? But when you are accessing, you can use either this or this, either this or this, because internally it basically knows that this a is basically a pointer constant, and that is how it is interpreted as, right? So this again firmly says that this a behaves like this one, integer asterisk constant. Is that okay?
Yes, sir.
Is it equivalent to int pointer a4?
Which one?
Sir,
Pointer?
the pointer a4 means, sir, we can define the first line, your first line of this.
Here.
We can define in this way, int pointer a4. You're not getting my point.
Pointer a4.
Yeah.
Okay, just a minute. You are talking about int pointer a4.
Yes, sir.
I'll come to it later. So how you read it? How you read this? Can anybody interpret this one? This is valid, but what does it mean? It's a good question, but what does it mean? What is the meaning of this? So the basic thing is how do I?
Pointer.
Sir, array of pointer.
Yeah. So you see, when you read this, through this path. So this is a is a array of 4 elements. What are the elements? The elements are.
So the
A is
pointer.
the array of 4 elements containing what? Each element is a
Pointer.
integer pointer. It's basically a array of integer pointers. And what is this? This is a array of
Integers.
integers, and this is a array of integer pointers. That's the difference. I'll come to it later on. Got the point? Who asked the question?
Yes, sir.
So now, so if I would like to store the address of A or A itself in a suitable pointer variable, what should be the declaration of that? Say in P. How should I declare P?
Int double star.
No, why double star?
Star.
What is the nature of A? You see, what is the nature of A? Int asterisk, right? So A should be assigned to P, which should be also int asterisk, because A is pointing to integers, right? A is pointing to integers, and P should also be pointing to. So P is should be pointing to. P is a pointer pointing to integers. That is what it means.
Sir, but A itself is a pointer, no, sir.
No, A is a pointer, but I am trying to declare. So A is a pointer, and I am trying to assign the value of A here. Here I am trying to assign the value of A, not the address of A. Assign the value of A. Value contained in A. If you can think of, I mean, there is no allocation for A. First of all, try to understand there is no allocation for A. There is not another additional. So apart from these 8 bytes, there is no allocation of space for A, right? That is implicit. But I am trying to assign the value of A into some variable that should be compatible as A, because the type of A is what? It is integer asterisk type, integer asterisk const. So this type I should declare here, P. Is that fine?
Sir, what is the value of A?
Value of A means A contains the base address of the whole array, base address of the whole array here. Or in other words, A contains the address of the 0th element of this one-dimensional integer array. A contains the address of the 0th element of the one-dimensional integer array.
Hello, sir.
Yes.
Sir, can we write address of A in the place of A? Because A and address of A are same as we have previously
Yes.
seen.
I understand there is ambiguity because of that. You say that A and address of A. So if I simply write address of A, both are fine. But the thing is, this declaration is all the same. So that might create a bit of ambiguity. I understand your point, because you say that now A, if I treat that A is a address, it's a pointer, so address of a pointer, but this is not the case. So I mean, to avoid the ambiguity, just consider that you are writing A here. That means the contents of A. I understand your point. I mean, if you look into that way, uh, you might be confused with that. So that's why let us assume that assigning the value of value contained in A. In fact, A is nowhere here, right? There is no actual location for it. So in other words, you can think that the nature of A, if you know, if it is integer int asterisk, you should be declaring P of same type. So it is integer asterisk and it is also integer asterisk. But what is the difference between P and A? If I write cout plus plus P and if I write plus plus A, which one is not allowed? This is not allowed, but this will be allowed, right?
Yes, sir.
What is the nature of A? It is integer asterisk. What is the nature of P? It's integer asterisk. But this is an integer asterisk constant and this is an integer asterisk like this. So if you write it, what is the nature of it? What is the nature of it? Got it? Got it?
Yes, sir.
Yes, sir.
Yes, sir.
So do as many times as you want. So what will be the value here? When you increment it for the first time, it will be changed to
2010.
then again it will be changed to
2012.
it will be changed to
2014.
2016. And if I write here, say after this, if I write asterisk P.
Hello, sir.
Yes.
Sir, I'm running out of data, sir. Can you please end up the class up to here, sir?
I'm not getting. You are running out of
data, sir. I have just left approx 20 or 30 MB, so I will.
Okay, fine. I mean, this will be this is getting recorded. So let me continue for another, because I have got the 2D arrays. I think it will be too much for you all. So let me wrap it up.
Yes, sir. Okay, sir.
Try to
Thank you,
think.
sir.
But anyway, the recording will be there. You can switch it off also. That's not a problem. Okay.
Yes,
so the
sir.
point is, so after this first increment, if I write asterisk P, what value it will be displayed? After this, if I write asterisk P,
2.
after this it will be 4. After this asterisk P, 6 asterisk P. After this it will be, if I write asterisk P,
garbage value.
it will be garbage, right? So the thing is, what I mean to say is, here if you know, after doing this, so after doing this, if I simply write something like this, say for I has been declared here, I equals to 0, I less than 4, I plus plus. Before I do that, if I assign the value of, say, P has already been assigned the value of I here, so I don't, there's no need to bother about it. If I remove this also, okay, so everything cleared. So here if I do something like this, P plus plus, and if I write cout asterisk P, what do I get? In each case, what do I get?
2, 4, 6, and 8.
Yes, so I can basically browse through the whole array, you know, use a variable. So A was a constant, right? So using A, I cannot, you know, update and keep on updating like that. So I use, so A was something that was pointing to this. So A was not actually there. So now I use some P here, which got this value 2008. And every time, so initially was here, then I incremented, it was pointing to here, then it was pointing to here like this. And every time I keep on, so using a pointer, I can, you know, change the I can increment and get into the get out. I can get myself placed outside each box after incrementing, and getting into the box is using the asterisk. I can do that. Is that fine?
Yes, sir.
Sir, you should give p plus plus after now, because this function will print only 468.
4. Okay, yeah. So yeah, that's correct. Again, I made a mistake. Okay, thank you. Is that fine?
Yes, sir.
So I had got the 2D also. Now that will be the end of the story. So the 2D makes the whole thing clear, because with 1D you may not have the whole thing clear to you. But let me do it in the next class. By the time you try to, I think these things are already done. Huh? So in your first year classes.
Not for the boys who were having C in second semester, sir.
Why? The second semester? Okay,
In the
because
second semester. Yes, sir. This.
in the second semester, what was the problem? The classes were there, but it was not properly taken because of the lockdown issues and all, right? Is that the case?
Yes, sir.
Okay. Anyway, so I think now it should be clear enough, because good idea and a level of comfort with pointers is very much essential to deal with C or C++. Otherwise, you'll a whole lot of mess. But you have got a data structure class also, I think. In the data structure, there is extensive use of pointers while using linked lists and all.
Yes,
So there it should have been done, right? You, or at least you yourself has been
Yes, sir.
would have been done that.
Yes, sir.
Data structures, how
Yes,
many
sir.
codes you have written? B tree, B plus tree. So whenever you try to write any piece of code for trees or linked lists, you need to encounter pointers. So I mean, just so these are basics, even basics of that also. Anyway, so this is important, because without that there are many things, and there's the memory layout. So that I'll discuss maybe in the next class. Okay, is there are there any questions?
No, sir.
Okay, then I'm leaving.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.